Hello, Algebra 2. Let's take a look at our 9.3a samples, where we're going to find the given trigonometric function with the given point on the terminal side of angle theta in standard position. And we're going to remember that our general way that we are figuring out the values for each of our trig functions based on our points where we have x's and y's and r's established. We can say that sine of theta is y over r, cosine of theta is x over r, and tangent of theta is y over x. So we're given this picture as a starting point. So we're told that the point negative at 1630 is on the terminal side of our angle. So our angle then opens up fairly wide. So here is the initial ray, here is the terminal ray, and so we're looking at what is the sine, cosine, and tangent of that angle. To figure that out, we're going to do some labeling. Now I've labeled in red the stuff I've added in after the problem was presented to me. So I went ahead and formed a right triangle based on the point negative 1630. So I dropped a vertical segment and a horizontal segment so that I have a right angle formed now, and I can label the sides of my triangle as x, negative 16, starting at the origin and going 16 to the left because my point here is at negative 1630. Negative 16 is my x-coordinate. And then I will proceed upward 30 to get up to my point negative 1630. So I can say that the vertical side of my triangle is the same thing as my y value. Now I'm going to figure out the r. So this comes from the idea of we can draw a circle through this point all the way around. This would be the radius of the circle then. And we're going to find out how long that radius is using the Pythagorean theorem. So here I am using that. 16 squared plus 30 squared is equal to r squared. That's 256 plus 900 equals r squared. R squared is 1,156, and r is 34. Now you are going to notice that I did not square negative 16, and I didn't because it's going to come out exactly the same if I square negative 16 or positive 16. So that's why I left it off, since it will come out a positive 256 no matter if I'm squaring positive or negative 16. All right, so my radius is established as 34. Now I'm ready to state the value of sine theta, cosine theta, and tangent of theta. Sine of theta will be whatever number is the y value over whatever number is the r value. Y we've established is 30. It's whatever the y-coordinate is over our radius that we have worked out to be 34. So sine of theta is the opposite side of my triangle. Here's my opposite, y, over my hypotenuse, r. 30 over 34 is 15 over 17 when we reduce it. We must reduce if we can. Cosine of theta then will be my x value, which is actually going to be my adjacent side of my triangle, over my hypotenuse, which is r. So x over r would be negative 16 over 34, which is negative 8 over 17 when we reduce it. Finally, tangent of theta. Tangent of theta will be the opposite over the adjacent side of this right triangle, with this angle being my theta angle. So it's going to be the y over x, which is my opposite over my adjacent. Y over x then would be 30 over negative 16, which is equal to negative 15 over 8. So we just have another new way to be able to write our trig functions. Instead of using opposite, adjacent, and hypotenuse, we can use x, y, and r when we're working on a coordinate plane. X will always be whatever is adjacent or next to the angle. The opposite side will always be y, and my radius will always be the hypotenuse when we're working on standard position of an angle on a coordinate plane. All right, that completes our samples for this lesson, so we're ready to move on to the quiz portion and our new material after that. We'll see you next time.